Welcome to my talk, Get Beyond Just Committing. I'm Dwayne. I live here in Chicago. I live up near Wrigley. I've been a developer advocate since about 2016. Arguably before that, I'm on Twitter at MC Dwayne. That's down at the bottom of the screen. So feel free to follow me on Twitter, tweet about this. I'm happy to talk about anything, this stuff included, but also outside of tech. I love improv, karaoke, rock and roll, knitting and crochet, which isn't on here, but all of those things are awesome in Chicago. Very brief, I work for a company called Get Guardian. I have stickers up here on the stage if you didn't already get one. They look like that, the one on the back of my laptop, which has the owl on it. So Get Guardian, just a quick show of hands, who here is familiar with Get Guardian? A couple people, that's awesome. Get Guardian is a platform that helps people detect secret leakage and manage it, remediate those problems. Last year, we found over 6 million API keys in public GitHub repos. We can help you find those before they get leaked and as they get leaked, and help you as developers stop leaking them. And if you all just quit putting hard coding your secrets, I'd be out of a job. So please stop hard coding your secrets, but also we can help with that. All right, enough about that. I'm happy to talk about that all day and night. But before we get any further, pull out your laptops if you want. This is very much a follow along the dotted lines, kind of a workshop thing. They'll challenge you to do stuff that maybe you haven't done before. And the only way you're going to learn any of this stuff is to type it. It's one of my favorite books. And it very simply says, you have to do stuff in order to learn stuff. Me talking to you all day, going to all this awesome sessions here at this event, jconf.dev, is not going to do you any good unless you actually practice and implement these ideas. This is true of my talk as it is for every other talk you saw today. So why am I giving this talk to you? Because we all rely on Git, or almost all of us do. Over 90% of respondents said they use Git. Who here doesn't use Git? All right, cool. Everyone in the room uses Git, for those of you watching at home. And most of the time, we're just doing these basic things, and we learned by route: git add, git commit, git push, pull, clone. We learned these things by route. And they're in our fingers, but what do we know they do? What we know those specific commands do. However, we run into situations all the time where we need to rebase something, where we need to cherry pick, where we run into, hey, run garbage collection in Git. And then we start working in things like detached head states, which is terrifying in most every other context you could possibly think of, except for Git. And Git is a superpower. Solving merge conflicts. These things are terrifying. They don't need to be, though. That's what I firmly believe. So part of the reason I'm giving this talk at a Java conference is, and it's not on my slide, Java is my first open source community. I was working at a company called Terracotta back in the late 2000s and fell in love with the space, fell in love with the tools, and watched as Subversion slowly got bumped out of the way for Git. But Git is very complex, and we don't sit down and just learn it like we do a lot of other technologies. We learn it piecemeal, and we have, like, again, 10 to 16 commands that we kind of know what they do, and we just use them and hope that everyone else uses them kind of the same way. Part of what makes this hard is that there's a lot of concepts in Git that get explained one way, when in reality they work slightly different. And it's easier to explain certain things like branching a little bit differently than it is to actually think about how Git really does it under the covers, because that's really, really like math intensive. And kind of like I in math, if you're anybody polymath out there, I is this imaginary number that makes geometry make sense, but it doesn't actually exist in our reality. The square root of -1 is very handy, and in physics even, how like quantum physics works is dependent on I existing, but I isn't a thing you can like wrap your head around because it doesn't actually exist. The concept of it exists. Git kind of works the same way in certain areas. So I'm encouraging everybody to share their knowledge with everybody else. This is my attempt to share at scale what I know about Git and where to get more info. So I already talked about why this talk. We're a quarter of the way done. Not quite, that's the short part. So we're going to talk a little bit about where Git came from, some of the concepts behind it. Then we're going to dig into the Git folder. And then we're going to look at the advanced Git commands. I say advanced because if you ask anybody on earth, where are you with understanding Git? What I found is 20% of people say, I am a complete novice. And everybody else is like, I'm intermediate. So what does advanced mean in that situation? I don't know. That's why I say advanced. So Git concept and history. Git is awesome and unique. Well, it was unique at the time because it takes complete snapshots of the file system. If you had to build Git from scratch, you would need 3 basic components: a compression algorithm to compress down your files so they're manageable little small chunks, a universal timestamp that we can apply to everything. We have one of those. It's called Unix time. It's 1.6 billion right now, some change in Unix time, and a way to mark down how we've made those changes and who made those changes. We can do that in plain text. It's pretty straightforward. So Git takes and compresses our file system at any given point in time. So it's smart enough that if you make a complete snapshot and then the next time you take a snapshot, you didn't change a file, Git's smart enough to say, hey, I'm just going to point back to the previous version. That's version B. But if I make a new change to A, I got to take a whole complete new snapshot. We move things around with diffs, but it doesn't store things in diffs. That's one of the real powers. It's also one of the real awesome concerns of Git is that you have full histories with all of your files at your fingertips. And so does everyone else that has that repo. So it changed these commits together, and that's what gives us our Git history. Commits are made up of blobs, binary large objects, that are literally compressions of the files with a bunch of metadata around it. So we can write down who made the commit, when the commit was made, and chain all this stuff together. This is just a laundry list of things that have happened. And like every other laundry list, like every other box you stack on top of another box, you have full, complete control over what's in those boxes and what order they're in. You can always change your Git history. If the Git history is public, people might have a problem with that, but just know you have complete control over Git. Git doesn't have control over you. Git also gives us these weird conceptual things like time travel and parallel universes with branching, which doesn't quite work the way I think most people envision it working, and it's actually more powerful because of that, or because the way it actually works, but we'll get into that later. I love that picture though. And unless you're this guy, Git can be confusing. Let's not forget, this is what Linus actually said in the first email ever where he used the word Git in the Linux mailing list. He was using it to manage his patches. I find a lot of times when I get confused about Git, and I still get confused in some areas, it's helpful to step back and think, why would Linus put this in here? What specific use case was Linus trying to solve? Managing patches for the Linux kernel is a very specific set of reasons. But that's how we end up with things like ish at the end of words. Any commit ID that, or anything you put in Git that leads you eventually back to a specific commit is called commit-ish. Anything that leads back to a tree, like a tag or the name of the tree or anything, any pointer, is tree-ish. What other language, what other part of computer science uses ish? Git rev parse, for instance. If you look up man, you type it in your terminals, if you got your terminal open, man git dash rev dash parse. I believe it's rev parse. But it's like pick out and massage parameters. Linus knows what that means. Gitster knows what that means. Maybe Matt Hudson knows what that means. I still don't know what massage parameters exactly means. So it's a little bit difficult because we have all these weird terms we've thrown out there. So it's okay. I'm here to tell you it is okay if you find this stuff a little confusing, a little baffling at times. Unless you're Linus, it probably is. I'm going to go ahead and skip to one of the end things I always tell people. Dang it, Git is the PG-rated version of a website. I'm not going to say on camera because kids might be watching. Little kids might be. Hopefully kids are watching and talks about Git. I really hope they are. But Dang It Git has just some wonderful tips on how to unstick yourself if you get into tricky situations and not sure how to unstick yourself. Including, let's forget this, let's just blow up the repo and start over. Who here has ever just blown out a repo and started over because they got stuck? You didn't raise your hand because you didn't want to raise your hand, but everybody's done that. If you've ever worked with Git, eventually you do it. One of the other weird things in Git is the concept of here. And it even says it at the top of git-sem.com, and that rotating banner. Everything is local in Git. Everything. This is a really important concept. In Git, everything is local to Git's perception of where here is. Luckily, it's very easy to identify where here is, and we'll talk about that in a second and how to find that. But I love that picture at the bottom. Gertrude Stein once said, she was an author in the 20s, said, the problem with Oakland, California is there's no there. She was living in Paris when she said that and making fun of her old hometown. So the artists in the 70s put up these signs, the here and there, so to prove her wrong. There's definitely a here in Oakland. I used to live about 5 blocks from there. I love this picture because no matter where you are, if you're watching at home on video, if you're there in the audience, or you're me on stage, you are here to you, locally to you here, and the word here is over there. Even if you're standing in, unless you're standing in front of the word here is wherever you're conceptually at, and there is over there. Even if you're standing in front of there, you are still here, and then here is over there. If that sounded confusing, that's intentional. Because that's how we all feel sometimes. It's like, all right, which way does this go? How do I, which merges into which? What is going on? Step back. What was Linus thinking? And where is Git think here is? And you'll pretty much figure it out from first principles. So let's take a really, really quick tour of the Git folder. I only have about 40 minutes left. There it is. Who here's ever looked inside their Git folder? Cool, now moving on. I'm kidding. The Git folder is the most important piece of Git. There are basically two sides of Git. There is the Git program itself, the CLI program, or Node-Git, or libgit2, or anything that accomplishes the Git protocols. The CLI that we all know is Git, the one you install and you're probably used to on the command line. And then we're not going to talk about that one in depth. That is written in C mostly, and C is really confusing to me. And then there's the Git folders. The Git folders are the individual units of Git organization. So a Git folder lives in every Git project and starts tracking everything from that folder that it's in all the way recursively down to, well, wherever. Most important thing and why I showed this image is the size of these things. So for those of you who have never dug into your Git folder, highly recommend cloning down a project that you have no real stake in. Now, I'm not saying do this in production work, but clone down and then just tear into it and start making changes. Just poke around and see what happens. Because if you blow up a repo that you don't really care about, well, reclone it. You don't care. But these sizes, these things are really, really tiny. The biggest thing in here is 8K, and it's something called index. Well, let's go actually take a look at what this thing looks like in real life. This is an example app that I play around with sometimes, based off Zork, kind of. But here's my Git folder. And I got these things called head. Who's ever actually examined head? Head is simply the pointer Git uses to say where here is. This is when you do a Git branch. This is the asterisk beside the branch. So Git branch. Yeah, I'm on main right now. And yep, sure enough, I'm on main. So let's do a Git switch. Switch is the replacement for checkout. It's a little bit easier to comprehend if you're brand new to Git, because what the heck does checkout mean? Switch means switch between branches. And let's just go to the last one I did, which was level 6. Oh yeah, there's head, it's pointing there. Switch back, there it is. Dash just says go to the last one. That also works for CD, if you're changing directory. But that's all it is. It's one line long. That's all it ever is. It's one line long. Git only references here one place at a time per folder. We'll get to that a little bit later, why that's not 100% true. What's this a reference to? Well, it's reference to your refs, your packed refs. So here's all the refs I got in the system. Except you notice, wait, I got a level 6 and it's not in here, because that's actually up here later, and I'll explain that when we get to garbage collection. But this is just a handy dandy list that Git says, okay, these are where all the references are. So the pointer Main points to that specific commit. What is that commit? That is a SHA, a secure hashing algorithm, checksum of the compression of the tree that you have committed. So when you do a git add, you say, all right, git, I want that version of my working directory. And when you say git commit, you're like, all right, take that, make a compression of all that, do a checksum, give me that checksum back, and we'll track it with that number. Git will accept up to as low as 7 letters or 7 characters. That's why you can do git checkouts and other git actions against the short SHA. But it's actually saying, all right, I know what that means. That's the full SHA. Anyway, that's what it's referencing. Origin head, well, that's where the head is pointing for branch, where head is pointed over on the remote origin, which just happens to be a thing. The first remote that default named origin. Origin's in the special name, it's just the first name. A description, this is blank in almost every repo you ever look in because we've kind of abandoned this for some reason. You can still name it if you want. Git config, yes, you have multiple ways to config Git. In fact, there are 5 levels to Git config. There is, let's see, Git config, and I'm gonna do config. I'm gonna do a list, and I'm going to do a show origin. Did I spell that right? Yes, I did. Hooray. If you run that, git config list show origin, list and origin are options, it will show you every config it has access to per that repo. So you can see, hey, there's a git config for my system. That's my system level. Then there's the global level, which you're probably used to working with. That's where you set your username, password. That's a public signing key. That's not a security concern. And if I keep going, oh yeah, that's actually where the config for this Git repo. I can actually override things in here. I can override my global at local because it loads system, global, local, and then tree, and then blob. I'm not going to demo tree and blob because I don't know a good use case for either of those. If you know one, please let me know. I've never run anybody that needs to set config per blob. Somebody does, though, somewhere. Again, Linus did at some point. But that's the config for this repo. And if I wanted to say, hey, use a different username email for my Git adds and Git commits, or my Git commits, not my adds, but my Git commits, I could set them per repo here in this config, and it would override my global. So I can be 50 different GitHub accounts at the same time. All right. We'll get into all the rest of this stuff later. But objects is the last one to show. I said earlier, Git storing these blobs, these binary large objects. Well, the objects live in this folder. And if we do something like a git log, I can see, all right, I got this commit that starts A026. I have a folder in here called A0. And there's a file in it called 2634. If I go look at that and inspect that folder, I'm going to look at it anyway, I can't read it. This is a binary compression. This is actually where that commit is actually stored right now, for the moment. And how did it get there? What was there? Well, that's, again, where index comes in. And if I look at index, it's going to look exactly the same. The only human readable parts are the file names. And everything else is just, it's a blob. But this is the actual file, and that's why it's the biggest file in the Git folder, it's literally the compressed files getting staged in one place for Git to go ahead and commit those things. That's your staging area. All right, we can talk about this particular thing all day, and I do have another talk that goes into all of those things. And we'll get back to a couple of them later. But the fact is, you can break a single Git folder, but you can't break Git. And that's a huge thing. Git is going to reliably work even if you break an individual folder. So if you need to reclone, reclone. I say experiment and be brave with something that's not production, that you're not getting paid on. Open source is great for this, but be brave around it. All right, the whole rest of this talk, the whole rest of the 30-ish minutes I have, plus time for Q&A, we're going to walk through these things. Don't worry, we'll walk through them. one at a time. And heads up, if you get motion sick from watching screens slide, you might want to look down until I'm like actually doing stuff, because I'm going to jump between 3 tools. My slides, VS Code. I use Sublime for everything else. VS Code for actually showing code, and command line Git. Quit there and clear. And a tool called gitkraken. In all transparency, I used to work for this company. I love GUIs for certain things. My favorite thing to use a GUI for Git is understanding where my branches, how my branches work, and for certain actions. It just makes certain things easier. I am not the person to say you have to learn the command line and command line only. I'm a person that doesn't like black boxes, but I understand how it's doing all of these things. So this isn't scary for me. This isn't like hampering me as a human being or developer. This is just a tool to get my job done a little bit faster. Gradle is a good thing. You shouldn't have to hand build every single thing every time. That's kind of the same argument of like you should only learn the command line. So those are the 3 things I'm going to be jumping between. First thing I'm going to talk about, Git squash. Git squash is the concept of take all of the commits and squash them down to 1. Who here has ever committed or done a Git push and you made like 10 to 30 commits and all they were typo fixes? Yeah, every hand in the room. This is how I learned about Git squash. I used to write docs for a company called Pantheon, or contribute to docs for a company called Pantheon. And one day the guy in charge of docs said, hey, you know, you can just squash these to 1 thing. I don't need to see all your mistakes. And it will make our repo a lot cleaner. I'm like, oh, well, what's that? And he sat me down and told me. So, ruined the surprise. Let's go back and look at one of my previous things here. Okay, so I am in, where do I want to do this? Yeah, I'll just squash all these together. So I can take these, and this is in the GUI, right mouse click, and squash 5 commits. Bam. Now I have all of those commits are 1 thing, 1 commit. And if I go over here and type, man, I love the manual, man, git squash, there's no manual entry. And this is one of those things that you hear like, hey, go squash this, or why don't you squash these down? And you go off on your own as a developer, or just anybody writing docs or anything, and you're like, wait a minute, what's squash? I could squash it with this tool that gave me a shortcut that just said, hey, squash the thing. And this is one of the problems with GUIs, is they hide some of the complexity behind black boxes. Squash, though, is one of these subcommands of rebase, the most terrifying, maybe, of all the advanced or intermediate commands. But rebase is one of the awesome superpowers of Git. It simply says, hey, I have this chain of commits that were based off of this 1 commit somewhere along the chain. And I can take that string of commits and move it and rebase it, move the base commit it's based on to the very top of another branch. And now I have a nice straight line instead of 2 branches. What this looks like alternatively, because this is one of those concepts I don't think you can over-explain, is this. This is the difference. Merge will leave your experiment, or will leave that other branch alone, and it will still hang out there. So we're on commit 2, and I made a new branch called experiment, and I made my changes, and now I got C4, and I got C3 with the other work I did in main, and I do a merge, and now I have C5, which is all of the changes from C4 and C3 as 1 thing. Rebase, on the other hand, if you ever run rebase, the very first thing it says in the command line is rewinding. So we did the same thing. We made a branch, and we kept working. But we said, all right, we're going to rebase C4. So what happens is Git, because it's time-stamped, literally rewinds history and says, I know what happened in every commit throughout all of my history. Let's go back and reapply all of those changes commit by commit. And this is a very simple example because there's only like, imagine this is a long branch. And and rewrite all of those changes on top of the current head of the branch, the current named pointer for the branch, and now we get a brand new commit that has the same old branch pointer pointing at the new thing we made. Meanwhile, our old branch pointer is still sitting there pointing at what it was pointing at. Because that's what main is. We used to call it master, and now we call it main. At least most of the world does. But it's just the name of a branch. What is the name of a branch? It's a pointer. This is one of those weird concepts in Git that I think we confuse because we think of branches as the Git flow chart, like the Git flow chart. And we see all these like branches with test and dev and prod and move it all together. And conceptually, it explains that process well, but really it's a spreadsheet. Git has the spreadsheet of the beginning of an event and the end of an event, and what those commits are and what those hashes are. And it has a human-readable set of pointers. We can point at any one of those commits, again, commit-ish, and that's all it is, it's just a human-readable pointer. So main isn't like something special that Git has to honor. It's just another pointer, and it doesn't care. Git's, again, the stupid content tracker. You don't believe me, type man git. That's literally what they called it, the stupid content tracker. So it's up to us to manage this, and this is where I think people get a little confused. Well, a lot confused. Our pointer for what we just did for the rebase now points at the new thing we made, in this case 4 prime. Meanwhile, the pointer back here is still a pointer, just hanging out. So now we're in this state where we have main and experiment. So how do we merge those two things together? Yep, merge. Git merge. Yes, after you do a rebase, you probably should do a merge in most cases. I say most cases because there's situations where with different options you wouldn't have done that. This is directly from the Git book. The pro Git book, I should say. I won't read it to you, but it's very true. Rebase is this awesome superpower you have for managing your local code, for managing your work. So if you're working in a feature branch, which I highly strongly recommend everybody always work in a feature branch locally, even if you're working in a tree, trunk-based development model, and you want to keep your branches in public spaces very small and like only have 1 or 2, still, feature branches locally are a great idea for just the safety they have. But before you push, if you are working in a trunk-based model, and you need to push to main, well, work in your feature branch, and then locally, make sure that you're still at the right place, and then rebase your work. Because to the end person, it just looks like, hey, I've added new commits on top of my work, not changed your work. But if you are pushing that out there, if it is a public branch, you probably don't actually want to rebase it. This is one of those things to have a conversation with your team leads and say, hey, I want to talk to you about rebranching. And when they run rebasing, when they run the other way, say, but I saw this talk, you should watch. And then send them this talk. Let's go and take a look at this in action. Which one do I want to use for this? Let's do level 5 for this. Where's a test branch? No, I want level 5. Do I? Yeah. Where's level 5? There it is. So I have this level 5 branch, and it was originally based off of down here. So if I wanted to rebase, well, first to check it out, because again, whereas here, it's there. So I want to rebase in here over to, let's say, I'll just rebase it to main. I can go ahead and drag it to, come on, cooperate with me. I'll do it from this branch. That's level 6. Okay, come on. I resized this. Yeah, let me do that. You gotta love live demos, people. Yep, there we go. I'll drag it on top, and in this tool, it'll say, all right, let me rebase this thing. And then it will try to move that branch on top of the other place. Admittedly, this is how most of you are not gonna do this. Most of you are gonna turn to the command line. You're not alone on the command line either. Who here uses VS Code for stuff? Cool. You have a whole world of tools for you. every IDE has a set of plugins that will help with Git. The one I'm going to specifically reference right now is called GitLens. Again, I used to work for that company that makes it, but you do you. So where am I? Git status. I'm level 5. So I want to rebase this to main. So I'm going to git rebase. And the most important flag for rebase, if you walk out of here with nothing else, -I, which you could also do as -- enter active. But I'm really bad at typing, as you can see, so I'll just do -I because that means the same thing. And then tell it where you want to rebase it, what pointer you want to rebase it on top of. And now GitLens is giving me this interactive map. Why I like this interactive map, or interactive tool for this, is it has a drop-down list instead of making me memorize these options. You can do this with Vim. You can do this with Nano. You can do this with your IDE. You can do this with any text editor. I don't encourage you to do this with Vim because you're gonna get confused. I know I do. And then you have to memorize things. Again, use tools to make it easier. But hey, there's squash, what we had earlier. So we can tell Git, hey, when we do this rebase, go ahead and squash that and this one and this one. But we definitely want that one. You know what? We actually don't need this commit. It doesn't have anything good in it here, so I can just drop that one. And that's the rebase it will do. It will rewrite my history for me. I think rebase is a terrible name. It should be git rewrite your history, but that's way too long. The base thing that Linus was trying to do was take this set of patches and apply it to his other work that he's already got committed, that is already going toward the Linux kernel. So that's why we get rebase. So that's the options you have. Squash, pick, reword. You can rewrite your commit message right then and there. Fix up, which does something I'm not going to talk about because that's a whole other 20 minutes. Drop, you can just drop commits entirely. Fix up, run, never mind. I'm going to stick to that. I'm not going to talk about it this time. And if you don't want the commit or the rebase to keep happening, you abort it. If you're doing it from the command line and you don't do interactive, you can hit these points where it's not sure what to do, and you can't abort it because it's just like, well, I'm in this weird state. If I just stop now, I've already dealt with these other commits in a certain way, and I don't know what to do. And that's the #1 reason I believe people drop entire repos and just reclone them because, well, I got stuck in the middle of a rebase. Who here's ever got stuck in the middle of a rebase? Yeah, that's every hand I see. Well, not everybody, but most people. All right, moving on. Cherry pick. Not going to demo it because cherry pick is just rebase a single commit at a time, typically from the end of a spear. I keep saying end of the spear, end of your line of commits. So who here has ever started doing your work and you got like, hey, I just made this awesome commit and then realized I did it on the wrong branch? Yeah, I think everybody alive has done that. You have multiple options there. One, you can save your work somewhere else, revert or reset that branch, go check out and then put it over there. You could stash your work, switch branches and reapply, or commits already exist, just git rebase or git cherry pick, which is its own command, and name where you want to put it. And wherever here is, it will take that commit and put it over there. This is one I'm not going to demo. This is one just conceptually. This is one you should go look how it actually works and get it in your fingers, because I think it will be confusing if I do it with my specific repo for you, and also for time commitment. Reflog. Reflog is your best friend. Reflog is the reason you never lose your work with Git. Because Git log, powerful as it is with all its amazing subcommands, it's not in this talk, but just to throw it out there, Git log -G and then put any term in quote will do a grep of your entire commit history for instances of what you're grepping in the blobs. Just next time you're looking for something, I know I'll put that in one of those commits. Try G. Anyway, git reflog, on the other hand, shows you everything that has happened for the last at least 30 days. I say at least 30 days because depending on what you're doing, it might be longer. It's definitely not going to be shorter. But where's reflog come from? Well, it comes from your logs folder. Inside of here, you have this awesome folder that, if I clear this, I see a beginning commit ID, a commit SHA, an ending commit SHA, who did it, what their email address was. Again, why do we have a name and an email address locked in lockstep with Git? Oh, because Linus was managing patches through a mailing list. That's why we use that as the ID. Universal timestamp, 1.664 billion. We're in Chicago, so that's UTC minus 0.5. Checkout moving from main to level 5. Yeah, that wasn't a commit. That was an action. So we're going to git reflog. Boop. I see, oh yeah, there's that ID. And there's exactly where it did. And I have a handy dandy marker of how far back in time I was. Just like with any other commitish ID or commitish reference in Git, I can. What's a good one? Yeah, let's do the rebase before I added that git ignore. Nah, that's not a good one. I'll just do one at random. So git checkout, and then I'm going to do head at curly brace, let's say 10. And now I'm going to attach head state. But I've checked out that version of reality. Whatever happened then. So if you ever wiped anything out in Git, like, oh no, I shouldn't have committed that. Oh no, I shouldn't have merged that. Oh no, I shouldn't have deleted that. Run reflog, check out that particular state in time, and then you're in a detached head state. So what's a detached head state? I haven't explained that. Well, we know what head is. Head. Notice how it's not pointing at a ref? It's not pointing at a named pointer. This time head is just a reference number. That's all detached head means. We don't have another pointer pointing at it. So it's detached from the pointer system. That's what a detached head is. So even as it says here, I can look around, make changes, copy things. I want to make a new branch, make a new branch. So, oh man, I accidentally messed up that rebase and I need to go back in time and magically undo it. All right, reflog, check out that state, git branch, name the new branch, switch to that branch, and you're right back to where you left off. You want to remerge that somewhere else? You're back in your normal workflow. To get back out of a detached head state, it's very simple. Git checkout or switch, and I'm going to go back to main. Head here is now there at main. Reflog is an amazingly strong superpower of using Git. Git GC, garbage collection. I don't know how many people are actually run into the need to do this because Git automatically garbage collects every 30 days or so, and every now and again on top of that. But sometimes you're working and it's slow. This is true if you're like working kernel, you're actually working on the JVM itself, like the actual code of the JVM itself, or like writing a JDK yourself. It can get like, wow, I'm kind of bogged down because I got so much stuff going on. Because remember that file we looked at earlier? Where is it? Objects. There's a lot of stuff going on here. And a lot of these have multiple files in them. And I got this thing down the bottom called pack and an info folder. So clear this out. So I'm going to run a git GC. And keep your eye on the object folder. Goes down to that. Where did they go? They got reaped and they got packaged with one of the coolest compression algorithms ever created that I don't know why didn't get used outside of Git, zlib. Who has ever even heard of zlib? Yeah, I got one hand. I had never heard of it before I started writing to talk about Git like 4 years ago. But yeah, it's this open source compression library that compresses text files exceptionally well. But that compacts them all down, wrote a commit graph binary for what was going on at the time we did that. Again, you can't read it. And then wrote to a pack file. That pack file, or it lists the pack file there, and then it builds the pack file down here, which is a super ultra compressed version of your history. Which, guess what? You can unpack and then run a ref log against it. Nothing's ever truly gone in Git. It's one of the horrifying truths of Git. If you have committed a secret somewhere, not to pimp my own product here, but if you ever do commit a secret, you're going to need to take some extra steps to make sure you got rid of that secret. Because if you just take it out and make another commit, that commit's still there. Even if you garbage collect, even if you packed it down, it's still there. And guess what? Hackers are going to look there. Guaranteed it. All right, that's GC. It's handy when you've been working with a lot of commits. You made 1,000 commits over 2 days. It's like, well, I should probably garbage collect now. So think in terms of order of magnitude. Again, if it's ever noticeably slow, it's like, hey, it takes like 5 times longer to do a commit than it should. Run a GC and it'll go back to normal. Git hooks. Who here has Git hooks set up? I ask a lot of questions in these. Yeah, awesome. A number of people. I didn't even know this was a thing before about 8 years ago, 5 years ago, 7 years ago, when I was learning to be a DevRel. But this is basically what it is, Rube Goldberg devices you can build. It's an automation platform built into Git. Why? Because Linus needed certain things to happen and scripts to run after he did a thing. That's it. Or before he did a thing. Matt Hudson did a great job of putting together this awesome website, githooks.com. Everybody should have this bookmarked because it explains Git hooks and gives a lot of references to a lot of awesome examples. There are 17 hooks built in. 3 of them happen before a commit happens. Commit message, prepare commit message, and pre-commit all fire off before the commit is actually implemented. So that's a good time to check if you've done something dumb before it gets to the commit. And what can you put in a hook? Anything you can script. This is an actual thing I run in most of my repos. I can ask dad joke. Props to Edward Thompson, who wrote the git dad, which is an awesome extension you can have that corrects when you type git dad to git add and also tells you a dad joke along the way. But that's how it does it. It curls icanasdadjoke.com and then puts an extra line. So I'm not going to read that dad joke. But anyway, my point here is that this is Bash. I love Bash. Absolutely, it's universal. But if you can script with it, you can write a hook in it, as long as it's available to that environment. What can't it do? I don't know. Ever hear of GitHub Actions? Yeah, it's just Git hooks on steroids. That's all it is. It's like somebody once described Jenkins to me as cron with knobs. That's what GitHub Actions are. That's what GitLab is. It's Git hooks with knobs. All right, bisect. Oh yeah, so how you use the hook folder. I forgot about that part. There's hook folder. There are a bunch of examples in here, mostly written in things like Bash and Perl scripts. Actually, they've cleaned up a lot of the Perl script stuff in the last big release, last few big releases of Git. Go in here, and it's like xgit update server info, which happens after post update, which makes sense. Post checkout, here's a command you could run, or that automatically runs. This is stuff that I have installed because of LFS, which we'll talk about later. But anything that's got a sample after it is something that came with it by default. So here's pre-commit sample. There's revparse with its verify head. What does this do? Again, Linus needed this. So it's in here for everybody. But you can put whatever language, anything you want in there. But that's how you make it actually pick it up, is take the sample off. So these commits actually, these hooks actually run. The samples don't. All right, enough of that. Moving on, Git bisect. Bisect is one of the superpower tools built into Git. It's basically, hey, how do I find where this bug came from? Really fast. through the magic of having, what's the maximum number of times you can fold any piece of paper? Anybody know? What? 11. 7 and 11 rhyme. But 11's the record. That's a very big sheet of paper. But the magic of having, there's only so many steps you can go through. So how this works is it's a tool like anything else. You say get bisect start. And when you notice, hey, there's something wrong. And then you say, I know where the bad state is. And normally that's wherever you're looking. So you can just say get bisect bad and it defaults to head. It's like, all right, this is bad. And then you say, well, I know it was good back here. And here I'm pointing to a tag, but again, it's commitish. That could be a commit ID, that could be a pointer, any other pointer you got. But okay, I knew it was bad back there, or good back there. So then it cut the graph in half. And then you checks out the one in the middle and says, all right, which is it here? Is this good or bad state? And then it's up to you as a human to say, yeah, this is good. And now it knows a good state and a bad state. So what does it do? It cuts the graph in half and checks out that commit. It says, hey, human, is this good or bad? And you say, get bisect bad. It's like, all right, I know a good state and a bad state. And you keep doing that until you as a human say, get bisect reset. I'm done with this. I know where I'm at. I know where it happened. What this looks like in detail, if I go to my bisect example here, I have check this out. I have a dumb example, but I like dumb examples. So I have an index file here because I think this is a perfect website. I click on that link, it doesn't work. Click on this link, it works fine. If I inspect this, inspect. Boop. Oh yeah, that's an HTTPS, that's an XTTPS. How'd that happen? When did that happen? Let's go look at my Git history. Bodywork. That is extremely unhelpful. Open a terminal here, so do a git bisect start. All right, it's waiting for a good bad state, so I know git bisect bad. There. All right, now it needs a good state, and I'm pretty sure it was good when I made it back here. Let's go look at the file real quick. Yeah, it says GitHub right there, just fine. Cool, so I know that particular SHA is good. Oop, I want to copy the commit SHA. Copied, okay. So git bisect good was here. Automatically checks out between those two. So now I as a human have to go say, all right, well, what's in index there? Hey, it's bad there. All right, I know that. All right, git bisect bad. Bisect bad. Oop, helps if I type git. And it cut the graph in half again between those states. It's good there. But I can keep doing this and having that. I'm not going to go through the whole exercise with this really short one. But now I can git bisect reset. But the point is, now that that's checked out, it's like any other detached head state. I can make a new branch. I can write down the git blame from there and go talk to that developer. I can do a lot of things. Git reset, and I'm right back to the good state, or right back to a good git state, because I'm done with bisect. That might sound like, okay, that was a dumb example, but imagine you're looking at this. Let's do a git log one line. That's what I have the index in. And you know that, hey, I found a bug here, and it was here, and it was here, and it was here, and let's go. Oh, I know this was a good state. That's where git bisect comes in handy. I have 1,000 things to cut through. Now I can get there in 11 steps or less. Probably less. All right, quit. Back to my slides. Where are they? Not my dumb website. Slideshow. Running out of time. We only got 3 more things to talk about. Two things. So remember how I said earlier Git can only point at one thing at a time with head? Well, that's true. But Git can also significantly link copies of itself around your directory system. Git work trees is the idea that I have one repo I'm working in, but if I put copies of branches and other parts of my directory system outside of this repo, I can go work in those just the same. And I can have a copy of my repo that Git knows about, that Git can deal with. I can have multiple heads open at once and work in that. So if you use git switch, or if you've ever been in dependency hell and git stash would kill you, or a production fire comes up and you cannot just abandon that work, you can't commit it yet, what you can do is do git work tree list. Where'd it go? Nope, here we go. Git work tree, come on now. Git work tree list. By default, I have one work tree. You always have one work tree, one working tree. But say I wanted my main branch, what am I in? Okay, say I wanted my main branch to live somewhere else, I could do git work tree add, and then say I'll go up a directory level and I'm going to do work tree main, and call it main. Naming the last thing I name it at is the branch I want. And now I have that over there. So if I change directory, so let's do git log real quick. And I am in bisect example. I guess I could have done that with status too. So git status. There we go, bisect example. Now if I change directory to that directory I made, work tree main, and let's do a git status here. I'm in main in this directory. Very important caveat here. VS Code still is pointing at the original work tree. Any changes I make up here, I'm making inside that other branch, not making in main. If I want to make it in main, I need to then point my ID there, work in another thing like vim to edit code. All right, but change back to my other directory. Git status, yep, right there. And if I want to delete that, that was not a great idea to add that. Work tree, remove, and get my git work tree list. I hate typing. And I'm back down to 1. That's work tree. Again, I'm not expecting everyone to walk out this room knowing that by heart. Go look this up. It's really awesome. It's been in the code since 2015. It's just nobody talks about it for some stupid reason. Git large files storage. Git's awesome at compressing text files. It's really good at it. zlib is awesome. It's pretty terrible at binaries. What do I mean by binary? Images, movies, audio files, anything that you're not going to change line by line, because that's how it deals with text files, line by line. So, large file system, or large file storage, is an open source project supported by every single Git hosting provider out there. No matter who you're using, they have this set up. With GitHub, it's a gig for free with your account. You can just stuff files into it. You do need to install it as a separate tool on your system. You can brew install it. Just go look it up. I'm not going to walk you through the install. And then you reference, hey, track this file, and it replaces the whole big file with something that Git's actually really, really good at tracking, and that is text. So let me show you that in, I think I did it in level 6. Nope. Which one did I do this in? Oh, I did it in main. Of course I did it in main. So here we go. I have this file called Zork Art, because I'm basing this dumb game I'm building kind of off of Zork, which is an awesome game. Who here has ever played Zork? Am I that old? Zork's awesome. This guy's got it. He's cool. Zork's a text-based adventure game. But that instead of stacking that image in Git itself and pushing it up to the server, it's 3 lines. You can do that all day. Doesn't slow down Git at all. It's a separate set of commands to deal with it, and has things called fuzzy to defuzzy them and actually render images and whatnot. Anyway, not getting into all that. Just know this exists, and you can start leveraging it right now. So if you have a repo with a bunch of images in it, don't slow it down. Start using Git large file storage and be good. All right, last 5 minutes. Dig into the internals. You can break the folder, you can't break Git itself. That's the best way to learn, is just go experiment. There's a ton of help out there, but if you're gonna read one thing, it's out of date. It still uses master instead of main, which I personally don't care for. And it doesn't have anything past 2014. So work trees isn't in here. Partial cloning, which I didn't talk about at all, is in here. But Git has the ability, just to mention partial cloning, Git has the ability to, instead of sending the entire blob over, just the metadata. So imagine you have 1,000 Docker images out there, or 1,000 Docker containers out there that you're managing with kube. And they don't need the entire history. They just need part of the graph. They just need the last set of commits. But you got to push over the whole repo to get it there. But you can do partial cloning now, where you can only send the metadata and only fault in what's needed as you need it. But that's a really paraphrased explanation. Go look it up. Shallow clones and, yeah, just look it up. Shallow cloning, partial indexing. Anyway, the Git book, though, is the basics. And it's free. You can go read it right now. Well, not right now. We're about to be done. And if you get stuck, there's awesome resources out there like Dang It Git. And I didn't put it in here, but if you go to the Git website, Git SCM website, under documentation, there is this awesome interactive cheat sheet that I can't recommend enough. That will explain how and when all of the commands interact with all of the areas, how Git sees reality. But that's it. I live in Chicago. I'm Dwayne. I'm on Twitter, MC Dwayne. I'll talk to you about any of this stuff. And yeah, happy to answer any questions in the few minutes I got left. And happy to talk to you after this and after the show.